All right, to do this problem, what you want to do is find the relative maximum of f. And for the love of all things holy, note that this is not the graph of f, but f prime. Prime. Seriously, like, you will lose all your points if you do not do this. You need to remember and check. Now, when I do problems like this, the first thing I consider is what is a maximum in terms of f prime when it's a maximum of f. In this case, a maximum is when it's going to start positive, go to 0, and then go negative. This is f prime here. This will create a hump like that, which creates the local or relative maximum. Now, looking at the graph of f prime, it's actually pretty easy to extrapolate this, since there's only one point where it does this. Now, 1 does not work because it never started positive. It's already negative, went to 0, and went back to negative. 4 does not work because we haven't been given a value here, and regardless, it starts negative. The only possible spot is negative 2, where it starts in positive, hits 0, and goes negative, and stuff. Alright, this is part B. Question is, on what open intervals contained in negative 3 to 4, the bounds of the graph here, is the graph of f, not this graph, this is f prime, both concave down and decreasing, as well as, this is very crucial, give a reason to your answer. Now this means that to get full points, you need to explain why. You can't just write a number. If you do that, you won't get all the points. So you're basically throwing them away. Now, to actually solve the problem, we're going to use the fun chart, f, which I hope you've learned by now, fun, f prime, f double prime, increasing, decreasing, positive, and negative. Now these we can use to prove it's concave down. So for any part of this graph, any interval to be correct, these two criteria must be fulfilled. And for it to be decreasing, f prime itself must also be negative because it's the slope. Very logical conclusion there. So just based on the fact that we know f prime has to be negative, we can eliminate negative 3 to 2, as in this part, f prime is positive. Now, f double prime has to be negative. Now this means that at any point where the slope of f prime is positive, not necessarily its position, but its slope, that can't be used. So for example, negative 1 to 1, it's approaching 0 from negative, so this area doesn't work. And 3 to 4 does not work, because in both of these cases, it's rising up. However, 1 to 3 and negative 2 to negative 1, it is going down, and f prime is negative. Therefore, the intervals are 1 to 3, and negative 2 to negative 1. These are your intervals x. Now, if you want to give a reason, quite frankly, the work provided should be enough. But just to clarify, negative 2 to negative 1 works because it is both negative and decreasing. As is 1 to 3. And sorry for that terrible handwriting, but I cannot write sideways. All right, cut. All right, this is part C, super easy. All you have to do is find the x-coordinates of all points of inflection for the graph of f. And again, remember, this is not the graph of f, it's the graph of f prime, as well as giving a reason for your answer to earn full points. Remember, you're just throwing away if you don't do it. Now, the very, very simple way to find a point of inflection is any point where f double prime changes signs. And you might say this is difficult if you have just f, although it's still possible. But you don't have just f. This is actually a graph of f prime, and as a result, this problem is super easy. You just find every point where the slope stops going down and starts going up. So there, there, and there. And then you're done. The answer is negative 1, 1, comma 3 for this reason. Easy peasy. Now, for part D, it is the most difficult, but you will not be using this graph. So, for some of you, I guess that's a good thing. Now, the question itself will require you to remember a certain part of the fundamental theorem of calculus, specifically in relation to integrals. But before that, let's just take it some key clues here. Clue number 1 is they want an expression for f of x. So no matter what you write, the end result should be f of x equals something, right? And this something would have to be good enough that you can actually use it to solve these two values. And remember to do it. It is obviously worth some points. Now, the specific fundamental theorem of calculus we're talking about is that any integral from a to b of f prime x is equivalent to f of b minus f of a. See? Now we can use this, and we can actually plug it in thanks to this other clue they gave you, that f at 1 equals 3. We can rewrite this problem, and we're going to do so now. I can get an eraser on. As, I'm going to move over so I don't break my arm. Rewrite this as the integral from 1 to x of f prime of x equals f of x, and look, there's our f of x from over here, minus f of 1. Now, the next step we're going to do is to finagle this a bit. We're going to take this original thing here, and we're going to actually add across. We can do this is algebra. We're going to add across this negative 1 f, or sorry, negative f1. So what you're going to end up with is the integral from 1 to x of f prime of x plus f prime at 1 actually equals f of x. And you might say, oh, but what's f prime of, or sorry, not f prime, f of 1. You might say, what's f of 1 actually given to you? So you can actually erase this and just change it out as 3 plus the integral from 1 to x of f prime of x equals f of x. Now that's the first part. The second part is to find f of 4 and f of negative 2. And we can actually use our equation to do this, and we're going to do that now. Pause the video. Right, now the final steps are to solve for f at 4 and f at 2, or sorry, negative 2. Oof, long day. Now, to do this, it's a mixture of things. First, we need to go back to our original information and use this. The areas bounded from negative 2 to 1 and 1 to 4 are 9 and 12. So we know that f prime at 4, the integral of it from 1 to 4 is 12. But, because we can look at the graph itself, we know that it must also be negative. So we're going to get 12 negative plus 3 equals negative 9 for f of 4. And the same is going to be used for f at negative 2. Now, negative 2, 1 is an area of 9. And we know that it's negative. However, we must remember that whenever there's an integral in which it is going backwards, essentially from right to left and not left to right, the sign is flipped. So it's going to be, instead of negative 9, positive 9. And 9 plus 3 equals 12. That is how you do this problem.